Confused, you check your tap, your sink, even your neighbor's faucet. Nothing. Then it hits you. The entire ocean. Every single ocean, sea, and large lake on the planet has turned into lemonade. Congratulations, Earth, you've officially become a giant cocktail. At first, it seems like a dream come true. Beaches now smell like citrus, and if you ever wanted to swim in a refreshing drink, you're in luck. But soon, reality sets in. The first problem, saltwater fish. Most marine life is adapted to salty, not sugary environments. Salmon, sharks, squids. Goodbye, friends. Within days, millions of creatures that relied on the precise salinity of seawater start to, well, dissolve in confusion. Some try to adapt by doing what any sensible organism would do, looking for a straw. Spoiler alert, it doesn't work. Shipping becomes chaotic. Cargo ships, once perfectly designed to float in water, now glide sluggishly through sticky lemonade. Engines overheat from the high sugar content, and the first few attempts at crossing the Atlantic end with vessels more caramelized than traveled. Cruise ships that once offered fine dining now serve more lemonade. People start wondering why their orange juice tastes suspiciously like the ocean. Then comes the weather. Ocean currents drive climate, and without regular salty water, currents slow down dramatically. Hurricanes? Supercharged, because sugar water heats differently than regular water. The Gulf Stream decides to take a nap. Europe gets a sudden tropical climate, while the Caribbean freezes over in a sticky winter wonderland. Meteorologists are left screaming at their screens. It's not just hot or cold, it's sticky hot or sticky cold. But humanity adapts in spectacularly ridiculous ways. Lemonade harvesting companies spring up, employing people to scoop, filter, and bottle the vast oceans. The global economy booms. For a while, everyone wants lemonade after all. But then reality hits. Sugar is corrosive. Plastic boats dissolve faster than you can say lemon wedge, and underwater metal structures start rusting at alarming speeds. Bridges over oceans, forget it. Submarines, only if you want to be trapped in a giant sugar jar. And let's not forget the obvious consequence. Thirst. Humans have evolved to drink fresh water, not a giant citrus cocktail. Attempting to hydrate with lemonade leads to sticky skin, hyperactive energy levels, and a worldwide epidemic of intense heartburn. Doctors are helpless. We recommend milk, they say, but even cows are refusing to drink anything that smells vaguely like the Atlantic. On a brighter note, tourism booms for a while. People flock to beaches for the lemonade experience. You can paddle in sugary waves, take a sip of the ocean, or build a sandcastle that literally sticks to your hands. But eventually, the novelty wears off. Cleaning up after sticky hurricanes becomes tiresome. Cities near the coasts find everything coated in a thin layer of sugar. Cars skid on the roads. Sidewalks turn into slip and slides. And the first global lemonade-induced traffic jam is promptly documented on every social media platform known to humankind. Science attempts to solve the problem. Could we desalinate lemonade back into water? Maybe. If we invent a global reverse sugar filtration system powered by nuclear fusion and giant hamster wheels. Meanwhile, biologists scramble to save species. New genetically engineered creatures emerge: the lemonfish, the citrus crab, and the sugar shark. They can survive in lemonade, but are prone to cavities and intense existential crises. Eventually, humanity learns a hard lesson. Even though lemonade is sweet, refreshing, and smells amazing, the oceans turning into it is not exactly practical. Ships still sink. Weather is unpredictable, and everyone is a little sticky all the time. You realize that life without salty water is, well, messy. But on the bright side, summer BBQs never run out of lemonade. So grab a straw, swim cautiously, and maybe, just maybe, consider that having oceans of regular water might have been the better choice after all.
What will happen if there is no moon? One night, without warning, the moon simply vanishes. No bang, no flash, no polite goodbye note, just gone. You go outside, look up, and instead of the familiar glowing orb, there's nothing but an empty black hole of sky where it used to be. At first you think, Well, that's weird, but maybe now I can finally see more stars. Sure, the night sky is dazzling without moonlight washing everything out, but that's where the good news ends. The first change comes within hours, the tides. The moon is the main reason we have regular, predictable tides. Without it, ocean tides shrink to about one-third of their normal size, controlled only by the sun. At first, surfers complain about bad waves, and coastal cities breathe a sigh of relief thinking, hey, less flooding. But pretty soon, ecosystems that depend on tidal movement start to fall apart. Shorebirds, crabs, and all the little critters that time their life cycles to the rise and fall of the sea get completely confused. Somewhere, a biologist cries into their tide charts. Then, the nights get darker, really dark. The moon reflects sunlight, and without it, even cloudless nights feel like someone dimmed the entire planet. Streetlights become our new mini moons, but that also means electricity bills spike. Stargazers cheer, but everyone else starts tripping over their pets in the backyard. After a few months, we notice something worse. The moon's gravity has been acting like a giant stabilizer for Earth's tilt. Without it, the planet starts wobbling like a badly balanced spinning top. Our seasons become chaotic. One year you might have mild summers and gentle winters, and the next you're roasting in 45 degrees Celsius heat in January or shoveling snow in July. Farmers throw up their hands and declare seasonal calendars a work of historical fiction. Meanwhile, the animal kingdom is losing its mind. Many species navigate or hunt using moonlight. Sea turtles who normally crawl ashore guided by the moon's glow now head in random directions, often toward parking lots. Wolves try to howl at street lamps. Humans who romanticize moonlit walks are left awkwardly staring at each other in pitch black. And then there's the big one, Earth's rotation. The moon has been acting as a brake on our spin for billions of years, gradually slowing the length of our day. Without it, that braking effect disappears. Over time, days start getting shorter. Maybe not enough to notice at first, just a fraction of a second per century, but give it a few million years and you'll be gulping coffee during a 20-hour workday. So people might be excited about less Monday, but plants, animals, and sleep schedules won't be happy. The absence of tides also starts to affect ocean currents, which in turn mess with the climate. Weather patterns shift unpredictably, the Gulf Stream decides to take an extended holiday, some regions get endless storms while others dry out into deserts. You might live in a temperate climate now, but without the moon, don't be surprised if you suddenly have beachfront property in the middle of a sand dune. Culturally, people struggle with the loss. For thousands of years, the moon has been part of our myths, art, and calendars. Poets start writing awkward odes to streetlights, werewolves file for extinction status, astronomers get sad emails from kids asking if the moon will come back if they say sorry to space. Of course, scientists immediately start debating whether we should replace the moon. Some suggest capturing a passing asteroid and shaping it into a giant glowing ball. Others propose putting a massive mirror in orbit to reflect sunlight like a fake moon. Elon Musk tweets about Moon 2.0 and immediately sells pre-orders for lunar condos. But there's no real way to get the original back. And as the centuries pass, humanity adapts. Badly, but we manage. We learn to navigate by the stars alone, develop crops that can handle unpredictable seasons, and invent artificial tidal generators for coastal ecosystems. Still, every now and then, someone looks up at the dark, empty sky and thinks, it's just not the same without you. In the end, losing the moon wouldn't instantly destroy Earth, but it would slowly unravel the stability that's made life comfortable. Tides, seasons, animal behavior, even the length of our days would all drift into chaos. And while we'd survive, the nights would feel emptier, the world wobblier, and the poetry a little less romantic. So if you ever see the moon, give it a little wave of appreciation. After all, it's been keeping our planet in check for billions of years, without even sending us a bill.
What if you tried to live on Jupiter? At first, the idea sounds thrilling. The largest planet in our solar system, a massive giant more than 11 times the diameter of Earth, with swirling clouds and colors that can be seen even through small telescopes. But from the very beginning, science makes one thing clear. Jupiter is not a place where humans could survive. Jupiter is a gas giant. meaning it has no solid surface like Earth. If you tried to descend into it, you would not find land to stand on. Instead, you would sink deeper and deeper through layers of hydrogen and helium gas. As you went down, the pressure would rise to crushing levels, thousands of times stronger than Earth's atmospheric pressure. Eventually, the gases would become so compressed that hydrogen would behave like a liquid, and deeper still, like a metallic fluid capable of conducting electricity. Any spacecraft or human body would be destroyed long before reaching such depths. The temperatures in Jupiter's atmosphere are equally extreme. The upper clouds, where sunlight still reaches, are cold, around minus 145 degrees Celsius. But deeper inside, heat builds rapidly. Near the planet's core, scientists estimate temperatures of around 24,000 degrees Celsius, hotter than the surface of the sun. No material we have today could survive those conditions. Even before facing the pressure and heat, you would meet another problem: gravity. Jupiter's gravity is about 2.5 times stronger than Earth's. That means if you weigh 70 kilograms on Earth, you would feel like you weighed 175 kilograms on Jupiter. For a human body, moving under such stress would be nearly impossible. Your heart would struggle to pump blood, your bones and muscles would feel overloaded, and standing upright could become dangerous. Radiation adds another layer of danger. Jupiter has the most powerful magnetic field of any planet in our solar system. It traps charged particles from the solar wind and from volcanic activity on its moon Io, creating intense radiation belts. These radiation levels are so high that they could kill a human within hours without heavy protection. Spacecraft that orbit Jupiter must carry special shielding, and even then, their instruments degrade over time. The storms of Jupiter are famous as well, especially the Great Red Spot, a giant storm larger than Earth that has been active for centuries. Winds in Jupiter's atmosphere can reach speeds of 600 kilometers per hour, stronger than the most violent hurricanes on Earth. Lightning there is also much more powerful, thousands of times stronger than lightning bolts in Earth's sky. Because of all these conditions, no solid surface, extreme pressure, high temperatures, intense gravity, deadly radiation, and violent weather, living on Jupiter is scientifically impossible. Instead, scientists focus on Jupiter's many moons, some of which may be far more suitable for exploration. Europa, with its icy crust and possible subsurface ocean, is one of the best candidates for finding life beyond Earth. Ganymede, the largest moon in the solar system, has its own magnetic field, which could help protect future explorers from radiation. Callisto, with its ancient surface and distance from Jupiter's radiation belts, is also considered a possible base for human activity. So while humans could never live on Jupiter itself, the planet still plays an important role in space science. Studying it helps us understand how gas giants form, how planetary systems evolve, and even how Earth fits into the larger picture of our solar system. Jupiter remains a planet to observe, to study with probes, and perhaps to orbit safely, but not a world where people could ever build homes.
Imagine that tomorrow the sun suddenly becomes twice as bright. Apartment windows glow even at night, streets become uninhabitable, and temperatures rise every hour. Does this sound like the plot of a science fiction movie? But there is real science behind it. In physics, there is a concept called the luminosity of a star. This is the amount of energy it radiates. The sun today has a luminosity of about 3.8 times 10 to the 26 watts. If we doubled it, we would have catastrophic consequences. Today, we will analyze what processes would begin on Earth, would people be able to survive, and whether such a scenario is possible in the future. Interestingly, we already see some of these phenomena in the solar system, on Venus, Mars, and even Jupiter's moons. Watch until the end, because we will draw a parallel with the real fate of our planet. Radical changes on Earth. Solar energy is the main source of life on Earth, but its excess is deadly. Energy balance. Today, the Earth receives about 1,361 watts per meter squared at the upper boundary of the atmosphere. When doubled, this figure increases to 2,722 watts per meter squared. This is as if we increased the power of the global greenhouse effect dozens of times in a few days. Atmosphere. The concentration of water vapor, the most powerful greenhouse gas, would increase. Climate models show that even plus 10% of solar energy can unbalance the system. Doubling turns the atmosphere into a heat trap. Oceans. In 100 to 200 years, the oceans would completely evaporate. Water from the atmosphere would gradually escape into space due to photodissociation, the breakdown of molecules under the influence of ultraviolet light. This explains why Venus is today dry, even though it once had oceans. Temperature. The Earth would become like Venus, from plus 200 degrees Celsius to plus 400 degrees Celsius. No modern technology would be able to withstand such conditions. Biosphere and life. What would happen to the living world? Plants. At first, they would receive twice as much energy for photosynthesis, but photosynthesis has a limit. Excess ultraviolet destroys chlorophyll, and overheating dries out the soil. Forests would die out first, steppes and savannas would follow. Animals. Those that depend on plants would not survive. Insects, which today make up 80% of the biomass, would disappear in a few generations. Only extremophiles would survive. Bacteria that live in volcanoes, near black smoke stacks in the ocean, in the Arctic or deserts. Examples from reality. There are microorganisms on Earth that can withstand temperatures up to 120 degrees Celsius. There are even so-called tardigrades, or water bears, that survive the vacuum of space and radiation. In such a world, they could become the new masters of the planet. That is, the scenario is follows. The Earth loses complex ecosystems and returns to the microbial level of life development. Humanity in the conditions of a double sun. Man survives thanks to technology. What could we do? Underground cities. Similar ideas already exist. Underground complexes are being designed in Singapore, China, and Canada. In such a world, the entire civilization would move below the surface. Domes and mirrors. A possible option is the construction of giant domes with a reflective coating. Such technologies are being developed for space colonies, NASA projects with solar mirrors.
Colonization of other planets. Interestingly, Mars would receive more heat in this scenario. If the sun were twice as bright, the average temperature of Mars would rise almost to the level of the modern Earth. That is, it would become the main candidate for a new home for humanity.
Space settlements. Physicist Gerard O'Neill proposed creating rotating cylinders in space back in the 1970s. In a world with a double sun, such O'Neill colonies would be the only safe option. But all this would only postpone the end. Long-term survival on Earth would become impossible. Is such a scenario possible in reality? Now the main question, can the sun really become twice as bright? No, it's impossible instantly. The sun is a stable star of spectral class G2. To double its brightness, it would have to radically change its stage of evolution. But yes, it will happen gradually. Every 100 million years, the sun's luminosity increases by about 1%. In 1 billion years, the Earth will become so hot that the oceans will evaporate. In 5 billion years, the sun will expand into a red giant and swallow Mercury, Venus, and possibly the Earth. Astronomical parallels. We see similar processes in other stars. For example, the star Betelgeuse in the constellation Orion has already become a supergiant. And stars like the Sun always go through a phase of increasing brightness. That is, in the distant future, the scenario of a double sun is not a fantasy, but an inevitable reality. If the sun were to become twice as bright as today, the Earth would turn into a second Venus. We would lose the oceans, the atmosphere, the biosphere, and ultimately the possibility of living here. But this shows once again,
Space is not just our home, but a challenge. The future of humanity depends on whether we learn to go beyond the boundaries of Earth. And what do you think? Will Mars or space colonies become our next home? Write your opinion in the comments, and subscribe to the channel to learn more about space and the future of civilization.
Imagine a planet made entirely of diamonds. Astronomers believe that somewhere out there, carbon-rich worlds exist, where mountains and even rain could be pure diamond. Black holes aren't just destroyers. They can spin so fast that they drag space and time itself around them, like a cosmic whirlpool bending reality. There's a star so large it could swallow our entire solar system. It's called UY Scuti, and if it replaced the Sun, Saturn would still be inside its surface. Dead space isn't empty. In the cold void between galaxies, there are rogue planets drifting endlessly, homeless and alone in the darkness. Neutron stars are the densest objects we know after black holes. A teaspoon of their material would weigh as much as a mountain on Earth. Astronomers have found planets where it rains glass, sideways. Winds blow thousands of kilometers per hour, hurling shards of glass across the skies. The footprints left by astronauts on the moon may last for millions of years because there is no wind or rain to erase them. Some stars are vampires. They steal matter from nearby stars, sucking in gas until their victims collapse or explode in violent bursts. Jupiter has a magnetic field so powerful it creates radiation belts that could fry electronics and humans within hours. Astronomers discovered a planet so dark it reflects almost no light, blacker than coal, a true shadow world orbiting its star. The coldest known place in the universe isn't in deep space, it's inside a lab on Earth, where scientists cooled atoms to nearly absolute zero. Saturn could float in water. Its average density is so low that if you had a cosmic bathtub big enough, the ringed planet would bob on the surface. There are stars that explode not once, but multiple times. They're called pulsating supernovae, coming back from the dead to blast the cosmos again. Astronomers have detected space cannons, fast radio bursts that release more energy in a split second than the sun emits in decades, and we don't know what causes them. Finally, here's a mind-bending fact. Most of the universe is invisible. Dark matter and dark energy make up 95% of everything, yet we cannot see or touch them. We only see their effects.
Imagine being able to look back 13 billion years and see how the universe was born. See the first stars, the first galaxies, and even the dawn of space itself. This was made possible by the most expensive and complex telescope in history, the James Webb Telescope. The idea for a new telescope emerged in 1996, when Hubble was just beginning to show the far reaches of the universe. It was originally planned to launch in 2007, but the complexity of the design turned out to be gigantic. A giant gold mirror, a cooling system, a sun shield the size of a tennis court. Each delay cost hundreds of millions of dollars. In total, the project increased in price 20 times and reached $10 billion. The telescope is named after James Webb, the head of NASA in the 1960s, who helped the United States go into space and prepare the Apollo program. After 14 years of delays, on December 25, 2021, an Ariane 5 rocket from the spaceport in French Guiana finally sent JWST into space. Today, the telescope is located at a unique Lagrangian point, L2, 1.5 million kilometers from Earth. There, the gravitational forces of the Sun and the Earth are balanced, and JWST can hang stably without consuming much fuel. The JWST's primary mirror consists of 18 gold-plated segments with a total diameter of 6.5 meters. And its sun shield of 5 layers of thin film protects from the heat of the sun, cooling the telescope to minus 233 degrees Celsius. All this is necessary to capture infrared radiation from the oldest objects in the universe. In 2022, JWST transmitted its first images, which amazed the whole world. It showed galaxies that appeared only 300 million years after the Big Bang. The telescope discovered the atmosphere of the exoplanet WASP-96b and found water in it. JWST photographed the Carina Nebula, where new stars are born. Its infrared photos allow you to see through the gas and dust that hide the stellar cradles. The Hubble telescope operates in visible light, JWST in infrared. Webb's mirror is 3 times larger than Hubble's. Its sensitivity allows you to see objects